anymore. Come out the door, your blanket's gone away.
Hey, welcome back everybody. Today's objectives are to discuss the properties of ions regarding the noble gas configuration and to understand situations where ionic bonds will occur, as well as to understand how to draw and show ionic bonds.
So to really understand what noble gas configuration means and why it's important, we should talk a little bit more about that. Group 18, which is the furthest to the right on your periodic table, those are called the noble gases. What's so special about them is that their outermost energy level is completely filled with electrons. And typically this means having 8 electrons in that outermost level. Since it's 8 electrons, and since all elements want to achieve this configuration, we call this the octet rule. Here's some examples. First of all, in the middle you see neon's configuration. Neon is a noble gas, hence it has 8 electrons surrounding it, which is the type of configuration all atoms are trying to achieve. So if you're chlorine, on the left you don't have 8, you only have 7. That's why chlorine wants to gain 1 extra electron to be like neon, the noble gas. Also, you need to be aware there's one exception to this rule. Helium is a noble gas, but it doesn't have 8. Helium is so small that it actually has a full outer shell of electrons with only 2 electrons, and that's okay for helium.
So let's take a look at ionic bonding. Ionic bonds form between a metal and a nonmetal, a cation, which is a positive charged ion, and an anion, which is a negatively charged ion, or to put it very simply, 2 atoms of opposite charges. Ionic bonding only occurs when the number of electrons that are lost equals the number of electrons that are gained. Let's take a look at sodium chloride. Sodium wants to get rid of this electron. Chlorine wants to accept it. Therefore, sodium, since it's losing a negative electron, it will be positive charged, and chlorine is gaining a negative electron, so it will be negatively charged.
So here's a fancier version of what Geis just told you guys about. You can see sodium comes in with 1 valence, wants to get rid of it. Chlorine comes in with 7 valence, wants to gain an extra 1. Sodium gives its valence electron to the chlorine. They become charged, plus and minus, and then the opposite charges stick together. That's what we call the ionic bond.
So now we're going to go over the steps in how to draw ionic compounds. The first step is to make sure that we have a metal and a nonmetal. When we look at potassium fluoride, the K is potassium, and it is our metal, and the fluorine is our nonmetal.
So step 2 of this process, you take your 2 element symbols and you put in their valence electrons. Potassium has 1, so you put 1 electron. Fluorine has 7, so you put in 7 dots around the fluorine.
The third step is to draw an arrow to show electron transfer. So the arrow starts from the atom that is going to give up the electron, and it points to the atom that's going to receive that electron. So here's our arrow. The electron's going from the potassium to the fluorine.
So here's what your final products look like. Notice potassium doesn't have its electron anymore and fluorine does have it. Step 4, the last thing you do is to draw in the charges. Potassium lost a negative electron, so it becomes positively charged. Fluorine gained a negative electron, so it becomes negatively charged, and of course they attract to each other for the final result.
Alright, so today's objectives were to discuss the properties of ions regarding the noble gas configuration and the octet rule. Just remember that all atoms want to have a full outer energy level, or full level of valence electrons. We looked at situations where ionic bonds will occur, such as a metal and a nonmetal, or an anion and a cation, or positively and negatively charged atoms that are in the same area. And we understood how to draw and show ionic bonds. Remember, we're drawing arrows starting at the one giving away the electron, going to the atom that is receiving the electron. Any questions, bring them to class.